Well, this is what's up right now. As you can see, local farmer got a hold of me, made an appointment, get this worked on. Aluminum stock trailer. It's got damaged braking welds there in the corner, both sides. That's coming apart. And there was a previous repair where somebody put a piece of angle iron, I say angle iron, I mean angle aluminum, across the bottom, and he took it off and he took a lot of wires out of the way. I see there was some brackets here. Some of the repairs that's been done to it was welding, and some of it was rivets and bolts. Each of the bottom corners has some damage too. There's a hunk missing out of this over here, and I can probably show you some more damage by opening the door. So let's do that. Open the door up, we can see where there's been repairs. Weld cracking right there. That's been gooped up with weld and plated, and at some point somebody did a repair plate there with bolts. Here's a welded repair plate that's failed. It's cracked, you can see right there. So there's some work that needs to be done on the door. See some welds there cracked. Here you can see where the good section of the back that's been missing for some time, and somebody was doing a repair and got that piece of aluminum angle and had that on there, had it bolted on, and they had right there's the bottom bracket that's supposed to be right there holding the door. So I've got some angle aluminum that I ordered for this new, and I'm probably going to be doing like a double plate back and forth across that bottom. And if we look in here where the corners are breaking, the customer took some plates out that were here, and in these sides, these were covered up with some aluminum plates that he already removed, so we could see where the wires were and try not to burn stuff up and have to fix if we can. And he found this plate right here. There's a heavy plate. I think this plate and the plate you see right here welded in, that's one solid piece of 3/8 aluminum plate. It's been cut out in that shape and welded in there on the inside, and it's like that on both sides, and it was done that way from the factory. And what that tells us is that even though this stuff's broke, a lot of that's somewhat structural but somewhat cosmetic too, because this plate here is probably more of the structure. And the way these corners are made, that corner block right there appears to be cast aluminum, which would be more likely to crack. But the plate that they've got, that 3/8 that's inside of there, is not cast. That's just a 3/8 inch aluminum plate. So we've definitely got some work to do here. Let's start on the bottom here, and we'll see what we come up with. I'm probably going to end up taking that door off. I can hook a hoist on it and take it off, but I want to see what's up with the bottom first and do some gouging cutting down there. I gouged that out at the corners, and there was bunch of weld gobbed up that was right at the end of that, and there on the end, I didn't bother like scarfing the weld off like I scarfed it off in those corners. I'm going to be basically putting that, I'm going to be covering all that up with angle aluminum. So I just, you see this piece and that piece right there, I just turned it up and cut those off. Now when I say turn it up, part of what I'm talking about is turning the heat up on the plasma cutter, which I turned up at that point because I had turned it down, and the reason I turned the heat down on the plasma is because that is how you would scarf these welds out, like I've done right here. And this is like what you do with oxyacetylene with a scarfing tip or a washing tip, or what you would do with a carbon arc to scarf a weld out. What happens is you run the air on your plasma cutter as normal, but you turn the heat down, and what that's going to do is it's going to prevent that plasma stream from piercing straight through what you're cutting, and it'll turn into more of a washing tip or a scarfing tip, where you're just going to scarf that weld out of the way and not necessarily make a straight cut going down through. I haven't sanded this any yet, but when I do, there's 3 things I'll be using, and 2 of them are flap discs. So there's a flap disc here that's been used, and I'll be using that everywhere I can. And the reason I say I'll be using that one everywhere I can is to prevent from wearing this one down. Because the reason I want to have one that's brand new available is because in an area where I got to get back in a corner, like right here, there's a portion of this where I'm going to need that sharper one. So I'm going to try to keep it sharp. I'm going to not use it for everything. The parts that I can get to with this one that's got some wear on it, I'll try and beat it up on the parts that I can and preserve this sharp corner of the flap disc on this one to reach in where I need to. And with aluminum and flap discs and sanding pads, you need a little hunk of beeswax. This is the greatest trick that I've ever found to counteract the effect of the way that aluminum will clog up and galled up your flap discs and sanding pads. You get your flap disc spinning, and while it's spinning, just real quickly bzzz, rub that on there and get that beeswax on your flap disc, and that'll go a long ways in making this thing last on that aluminum. I think I've spoke about that before. I don't know how it works. I've picked it up from another YouTuber, and he picked it up. He said when he was talking about it that he picked it up from another YouTuber. But that is using the beeswax on your flap discs and sanding pads on this aluminum. It's a great trick. I'm glad it's being passed around, and if you haven't heard of that before, I want to pass it on to you now, because every time I've ever used flap discs and sanding pads on aluminum, that's the main issue, is that soft aluminum just clogs them up right away, and you need that beeswax to get some life out of those tools. Now, I'm going to do the sanding and everything on this, and then the next step obviously will be cutting another piece that goes on top of even that piece and on the top part of the trailer. But one of the things that takes a little more time with aluminum, and since there's places on this I'll have to weld before I can put the other one on, so I'm going to go ahead and do the cleanup and do that welding. One of the things that takes a little more time on aluminum with the cleanup is, like I've got that clamped up right now. If that was steel, I could weld it. I'm going to have to mark that everywhere it makes contact with the aluminum and clean that up. Even the places where I'm not sanding, you're going to have to clean it up. Now for that, I'm going to power brush it with a stainless steel power brush, and I'm going to use a lower RPM tool, because I don't want to power brush that with one of these 12,000 or 10,000 RPM grinders. I have a variable speed grinder here with a stainless steel power brush. It's not the knotted type. I don't want to be aggressive on this aluminum. This is the unknotted stainless steel on the variable speed tool. So we're talking about spinning this at the most 3,500 RPM. And so I have a lot better results on aluminum with the power brush with the lower RPM. So let's get to work. A couple things I noticed right away. I was getting my marks on here where I'm gonna sand and where I'm gonna power brush and whatever. I was just using a Sharpie, and there's obviously a considerable size piece of aluminum missing right here. I'm gonna have to cut a piece and put in here. This part of it on the outside here is not as thick as that. This is about 1/8. I've got some I can put in there, but obviously I'm not going to try to weld that shut. I'm going to cut a piece of aluminum somehow and put in there. Another thing on the other side, or the same thing on the other side, I'm not really missing as much over here. There's not a hunk missing, but there's a gap that doesn't look like it'll pull completely together. What I'm likely to do right there, I might get a 1/8 inch aluminum TIG rod and do some hillbilly TIG action with the 1/8 inch rod filling the gap and pulse the MIG welder by hand with the spool gun and weld that up that way, and that would be fine. Another thing I noticed when I was marking this, there's been several times, if you look at these, see that chain moving? There was a couple times that bungee cord was actually swinging. That's from the wind with this door open right here. I'm not going to be able to weld this like that with that door open. I'm not going to try to do that. This spool gun aluminum MIG and TIG, especially on aluminum, it's critical that my argon shielding does its job around that wire while I'm welding, and that wind could cause me a major issue with that. I'm going to have to move some stuff out of the way and use the forklift to bring this trailer in and be able to shut the door when I'm welding, because I don't want to take the risk of welding along and the wind blows that argon and makes a big mess. You have to have shielding with any MIG or TIG welding. Your gas is critical, and on the aluminum it's even more critical. So that's got to happen. So that's next. That material was actually a little thicker than 1/8 of an inch, and I had a piece of 1/8 that I had folded before in the break, doubled over, and I cut and put it in that corner, and then I built that up with some weld and welded this up. I was actually able to weld this up with the door open, but I've got the trailer, the areas I'm welding, a lot further away from the door. I've moved it back quite a bit. So now I'll be cutting another piece of angle to fill in this big hole, just, you know, covering the top like that, and I'll cope it out for the ends here. So then I'll put that in place and see what I got to clean up and get it welded on. The way this top angle is notched, see, there's a piece looked like that cut out of this angle here on the top, make room for that post so that I could have this piece still running all the way to the end. So it's overlapped, and I've power brushed all this where it makes contact with the trailer so I can weld all this up. I've welded that, and that door latch, I put that on there and drilled and tapped and bolted it on. I can't reach to put nuts behind that now, the way I boxed that in. I drilled and tapped that, which normally I wouldn't let it slam. This was where I had to add a piece. Yeah, I drilled and tapped that for that door latch. And normally, the way these are done, they have steel bolts that go through. They come in from the inside where you got access. The way I did the bottom, I don't have access to the inside, but they have these nuts that are smooth. I guess so that somebody couldn't steal your livestock with a wrench, but that's not a concern for this feller. And where I drilled and tapped that, you know, drilling and tapping aluminum is not the greatest thing in the world because aluminum's soft. That's why the manufacturers, you know, like right here on these hinges, they got aluminum hinges, but they got steel bolts in them because they probably wanted to harder, you know, something harder as the pin going through there. Just like the way they do them latches, they got steel bolts, you know, holding them. The only reason I think drilling and tapping that's going to be okay is because the way I just double plated that with a piece of angle and then another piece of angle, I've made that a 1/2 inch thick. So that aluminum that I tapped, it's, you know, it's 1/2 inch thick. And I put blue Loctite on them bolts once I tapped it and threaded them in. So I think it's going to be all right. Like I said, the way I boxed that with that angle iron, I no longer have access to the inside of that to put nuts on there or do anything different. So drilling and tapping is what I did. So the next thing is going to be looking at this door, seeing what I can do to fix the issues we saw earlier on it. And I think I'll probably get this thing in position under the hoist where I can take that door off and maybe work on it on the table. So I'm probably not going to do what I was just thinking I was going to do. I was thinking about taking this door off, but I'm taking a look at it with it here on. We got this huge mess that's been patched and repatched and welded and bolted and all that, and then there's this patch right here that has broke. So across the top there's obviously an issue, and I'm realizing the aluminum angle I've got left is long enough to go all the way across the top of that, and I just shut this door and there's plenty of room. If I put that on the inside like this, put that on the inside, there's plenty of room that would clear to put that angle across there, and that would really stiffen that up. But what I got to consider is when I cut all that apart, this thing's probably going to shift. And I want to make sure it latches back where it's supposed to, where I've got it latching good now. There's another way I can get into this trailer. So I think what I'm going to do, I'm going to cut that apart, take my measurement and cut my angle for that. And I'll probably close this door and go around the other way from the inside and do the welding. So I'm welding on it with it latched the way it's supposed to be latched. That way I can be pretty confident that when I get all that welded up, that this door will be squared up where it's supposed to be. you look up here on top of this thing, you'll see where I had to notch that. And I've stitched it. So that angle, I think, will really help that a lot. And the next thing's going to be, there's cracks in these corners. Both the corners had cracks. I had to take that latch off, that top latch right there. And then I took my carbide burr on the high-speed end grinder, and I've gouged this out where these have these cracks. Of course, there's a bolt hole in the center of that one. That's one of the holes that door latch bolts on. Something about these carbide burrs. If you look at the one I'm using right now, not all of the carbide burrs have the teeth that are that far apart like that. A lot of them, those teeth are a lot closer together. These work really well on aluminum. They still get aluminum stuck in them. But the ones where the ones for steel, where the carbide burr teeth are really close together, they fill up with aluminum so fast you can't even use them on aluminum really. Right here's a type of burr bit that you'd normally use for steel. See how close together those teeth are? Those don't work on aluminum very good at all. They just fill right up with that soft aluminum. So on these corners where I gouged out with the burr bit, I welded this up with a TIG. And on this, this entire vertical needed re-welded, and there was a crack that just went a little ways on the horizontal. And I'm not a very good TIG welder. I'm not very good at TIG. I'm especially not very good at TIG on aluminum. It was cracked on the top too, so I welded that. And I'll show you the other side too. So this is the other side, and this is where I took that latch off there. And there's no crack in the horizontal on this. But I did re-weld the vertical, and I'll have to do a little sanding right here to make it flat for that bracket to go back on there. Although I may put something over this, I haven't decided yet. You know, down there I added so much with that aluminum angle, I actually brought that out, a little ways because I put that aluminum angle on there. That should actually down there be sticking out a ½ inch more than up here, but the door shut okay, so that wasn't an issue. So this hole might have to be drilled out a little bit, and this might have to be sanded off to put that back on. But I had welded here and here and here with the TIG. And I'll be honest with you, what I actually did on that, I ran a bead over that, and it didn't look too bad, but it didn't look great. But it was like a very convex bead, and I was realizing that was an area where I needed it to be flat because I was probably going to sand it off. And since it was convex enough that there was quite a bit of reinforcement, I thought I could make it better by flattening it out, and I took the TIG without a rod and just ran over it. So that's the way I kind of got it to flatten out. I ran a pass over it when I was done without adding any filler. And a couple things on that surprised me is how much heat I had to run. I ended up with that Primeweld on, I think, 175 or 180 with a 332 blue tungsten. And I didn't think it would be that high, but that corner section there is cast. That's a piece of cast, and I looked in there, and it's a heck of a hunk, and with the other bracing that's behind it, there's quite a heat sink there. So Go check out what I got to do next. I've opened up the entrance to the front and come through. So I'm inside the trailer. Check this out. What I come in here to look and wanted to see with the door shut, this is the inside of the area where I was just working, you know. And I was I'm gonna get the spool gun and MIG weld that crack right there. But I was wondering what else I could do right there and right here. That crack is cracked across there, and there's a little crack there and there, which obviously I was gonna weld that up. But I wonder if you're seeing what I'm seeing about what else we could do here, because the way this door is, there's nothing interfering that would stop a guy from putting a gusset right here. And I think if anything was going to make a difference in that cracking, I think a gusset right there, boy, that should help that a lot. And I think if, you know, it's clear to me that that's not going to affect that door. I've got a whole width of my finger right there clearance that way, so I think putting a gusset in there would be the thing to do. Realized there a second ago, I forgot to mention something. I may have mentioned it before about my TIG machine. On my Primeweld, I don't have a foot pedal. I have a foot pedal for it. I can hook it up that way. But the way I run it is with a TIG button. And this TIG button, you can get one at tigcontrol.com. I'm not affiliated with them in any way. I'm not getting anything out of it. I'm just telling you. This is a situation where I have to get on a ladder to weld that. It is really tough to run a foot pedal when you get up on a ladder. And other times when I've been up underneath of something, or there's just sometimes that it's really tough to be able to run a foot pedal. But this TIG button is just, to me, it's amazing. I can't believe how sensitive the thing is. But let me show you. See, on this TIG torch, there's this button. And this button works just like a foot pedal. And the harder I press that button, the more amps I get. And if I release pressure on that button a little bit, I get less. And when I let off of it, it's just like letting off your foot pedal. This is the controller that you mount on your machine. And of course, you know, it hooks up. You'll have to get whatever one that your machine takes. But they do make it for my Primeweld 225. And I guess the only thing I would say on the Primeweld, I think I've seen enough videos to convince me that even though I'm not a very good TIG welder, the Primeweld's a decent TIG machine. Now, I'm not going to say that Primeweld is a dynasty. A Miller Dynasty, you're talking a lot of money, but it's probably a better machine. And it's probably something, you know, there's a lot of lower cost things like this that you run into, and you just got to develop your own opinion on it. I personally don't have enough use for a TIG welder to justify buying a Miller Dynasty. That's the reason that markets are existing and worthwhile for items like this Primeweld, because, you know, if it weren't for the low cost of the Primeweld, I probably wouldn't have an AC TIG in this shop. I just don't use it enough. And even since I've got that machine, I wouldn't say that it's no moneymaker. In my area, with what I do, I could do everything I ever wanted to do with a spool gun that I got when I got my Millermatic 252. And if you buy your spool gun with your Millermatic, I think you get even a discount. If you buy it at the same time, they give you a pretty good price on it. But like I say, I mean, I TIG'd that because it was cast, and there's certain times when, you know, you might want to use a TIG. But if I didn't have that TIG machine, I'd have wire welded that and not worried about it. You know, just do the best you can. And because I'm saying it's not worth paying what it costs for something like a a really good TIG machine like a Miller Dynasty, it's not worth paying that if there's no way that you're going to do enough TIG welding to cover the cost of that and make a profit. So next thing's going to be, I'm going to cut some gussets and I'll MIG weld them in there and we'll keep going. I got a couple gussets cut out of 1/8 inch plate aluminum, and I wanted to mention, just in case somebody didn't know, I cut those with this circular saw with a wood blade, you know, a blade for sawing wood, got carbide teeth. And yeah, you can, just in case you didn't know, you can cut aluminum with just about any power tool that you use to cut wood, as long as it's, you know, one of the ones that's got carbide teeth. And that's the case even with maybe your jigsaw. You know, you can get blades for cutting wood for your jigsaw that have carbide teeth, and they cut aluminum great. You can use a wood router on aluminum. Actually, people that work really thick aluminum and have to bevel it, it's a pretty standard way that, you know, they get the right bit for whatever bevel they want. You could run that right down a piece of 3/8 aluminum, put beautiful bevel on it for welding or whatever. Just wanted to mention that those woodworking tools, they do work good on aluminum. So I used a spool gun and welded those gussets in there and welded that crack up in the corner. Seems like since I got my Millermatic over the last few years, I have gotten a little bit better running the aluminum with that spool gun MIG. The tips I'd give on that is always point towards where you're going at a pretty sharp angle. You need to use a sharp angle and push it. It offers a cleaning action. I do a lot on steel too, not always on steel, but always on aluminum. Even those vertical uphill welds I made on those gussets right there, I'm pointing that thing pretty sharp angle where I'm going. And there's a cleaning action that takes place when you run it that way, and you really need that cleaning action on aluminum. The other thing I've noticed that seems to help me on aluminum is don't be afraid to turn that argon up. I generally, on a standard, like with my steel mix gas that I use for MIG welding with steel, you can get away running that on 10 or 15. Sometimes I put it on 20. Now, the argon that I'm running on a MIG on aluminum, I often find myself turning that thing up, man, 35, 40 cubic feet per minute of gas. And it just seems like it helps, especially with the contaminated material. You wouldn't think that running that much more gas than 20 would make a difference, but it seems like it does to me. Definitely helps. So that's it for this one. I hope you got some tips out of it. I'm sorry it wasn't more entertaining. I haven't had a good week. And I'm on some antibiotics that's kind of upsetting my stomach. So I'm just trying to soldier on. Glad to get this taken care of for this guy. Really good guy. Hope he's happy with it. And so that's it for this one. Thanks for watching.